right, our first afternoon presentation is Dan Press. And Dan, I will let you take it away.
All right, thank you. Hey, everybody. So my name is Daniel Press. I am one of the owners and founders of PrimeTest Automation. This is my, I'm coming out of hiding right now. So I've been a LabVIEW user for a very long time, and I've never given one of these speeches. Why was that? Well, I think part of it speaks to the quality of the other speeches that have come before me. They've been so good, I didn't feel like I had much to add. The other reason is the stuff that I do in LabVIEW is what I consider to be the best part of what I do, the most fun, the most enjoyable part, but I get caught up in doing a lot of the other parts. And so there's not as much time to put together presentations like this. But lately it's been apparent, as Jim mentioned, and as is obvious, that NI is shifting focus, and I think the community is kind of filling that gap. And I really want to be part of that. I want to give back. I've had a lot of great experiences. I've soaked in all this information, and I want to kind of put it out there. So I'm a certified LabVIEW architect, certified LabVIEW embedded developer. I'm a DQMH trusted advisor. As a company, we are a trusted advisor company. So we are supporters of DQMH, and our recent projects, we have incorporated on top of DQMH something called DTS, which is the DQMH test sequencer. That's what we're going to talk about. For those of you who do not use DQMH, or maybe Actor Framework or other frameworks, I have this message for you. And that is really, it's another tool in the toolbox, right? So I'll make another analogy. My 8-year-old son is a dancer, and so is my wife, and kind of I am too. I'm a social dancer. They're actually taking real classes. And guess what? You guys are all dancers, and you guys have a whole set of dance moves that you use on a regular basis, depending on what kind of music is playing, the music being the requirements, right? So I'm going to teach you just like a couple extra dance moves today. That's what it is, all right? So you may use them, you may not. And if nothing else, you may gain more confidence in the framework that you use because you see how bad this is. I don't know. Let's see. Let's go on to see if my slides work here. Okay, so in the spirit of Our Giants Are Female, I want to talk a little bit about Dr. Edith Mathiowicz. So she is a full professor of medical science and engineering at Brown University. She comes from the world of chemistry and then kind of drifted into biomedical science and also engineering. She did her undergrad at Tel Aviv University and then her graduate studies at the Weizmann Institute in Israel. And then she did a postdoc at MIT with Professor Robert Langer and came up with some concepts for polymer microspheres, specifically biocompatible polymer microspheres for drug delivery. And in the early 90s, 1991, she came to Brown, started doing research there and teaching. And by 1994, she was granted dual appointments in the Department of Engineering and in medical science. And fun fact, she's the reason why I know LabVIEW. When I was an undergraduate there, I got to work in her lab. So it was a great experience. It was definitely the most valuable thing I got from my university experience, partially because I learned LabVIEW. And when I say learn LabVIEW, I want to expand on that a little bit. So I got thrown into the absolute deepest of the deep end of LabVIEW when I was just an undergraduate research assistant in this lab. And what you see there are a couple of images from a book that was published in 1999, but it was dealing with what we were working on back in 96 and 97, even 95. And it was this instrument called an electromagnetic bioadhesive force transducer. So what is all that? Basically, they're making these microspheres. These are going to be designed to replace injections, ideally, So one application would be like for insulin. So if you have someone who has to take an injection of insulin multiple times a day, wouldn't you rather just pop a pill? And if you could, you need to get that insulin past the stomach where it normally would get broken down by all your stomach acids and digestive juices and everything. You really want to get it into the intestine so that it can just release into the blood. So you have to be able to design a specific polymer that is good at sticking to the tissue in the intestine and bad at sticking to the tissue in the stomach. And so this instrument was designed to test various formulations of polymers for their bioadhesive properties. So it's a test and measurement system. And it was my first one I was kind of faced with in a real application. If you look at some of the elements here, you've got, okay, all these things, and apologies for some reason the authors misspelled LabVIEW on one of the graphics and spelled it right on the other one. So on the little computer monitor, it's got lowercase IEW. But down here, they got it right. So you've got video analysis. Remember, this is the mid-90s. We've got imaging. That was a BitFlow Raptor board running the Concept VI library from France. We've got data acquisition. That was an MIO card. That's an NI product. We had GPIB talking to a power supply. We had power amplifier circuitry that we built, digital power relays. And then we had motion too. We had X and Z motion, X, Y, and Z motion, focus servo. We had a pH meter, all this kind of stuff. We're basically looking through a microscope at a tissue sample with these microspheres and an electromagnet. And the microspheres had encapsulated some iron particles, so they were magnetic. And we could crank up the current in the electromagnet. And the goal was to levitate the sphere as we move this tissue sample further and further away. So absolutely got thrown in the deep end of LabVIEW. I have Professor Mathiowicz to thank for that. She is, as I saw on the previous slide, she's the founder of multiple companies. She's got some dozens and dozens of patents to her name. She's definitely a huge force in the field of polymer drug delivery systems, and she's still active today. She's still teaching, and it's a great thing. She's an awesome mentor. She was so inspiring to all of the undergrads and the graduate students in the lab. So I thought I'd open up with that, and it's kind of an introduction to where we're going with LabVIEW here. Okay. So let's talk a little bit about DTS. So DTS is the DQMH test sequencer. You guys saw a little bit of DQMH from Enrique's presentation earlier, which was really cool. That tool that he put out there, I'm actually using. If you want to look at what DTS is, essentially it's a project template. And along with that, it's also a DQMH module template. The specific module template is a test step, and the project template is the test sequencer itself. And the test sequencer is broken into a few modules. As you can see here, it's the framework, of course, the configuration module, and the logging module. It looks on a LabVIEW project, it kind of looks like that. So you have several libraries there. And in this case, this would be like a test sequencer with one type of test step is what you're looking at. So we'll do a little demo here. Let me get out of my slides. And demo. So out of the box, that should look a lot like what was on the slide. And I will do some zooming in here, but let me just run this. Okay, so out of the box, you get a runnable kind of application here, and it's asking you to scan a serial number. Well, they put a little trick in here where if you don't scan a serial number and you just type config, you get the configuration editor. Okay, so that's the configuration editor there. And basically what the configuration editor is it does two things. It lets you edit the sequence itself, and it also lets you edit each one of your test steps or the configurations for your test steps. Okay. So that's the configuration. I got one step. It's very boring. Here's my test step, and I have a limit of 100. Okay, that's great. All right, so can we get out of that? We're back into, okay, I want to run a test. We'll put in a serial number. It's going to run this test. It's going to say it passed. That's great. And then just come right back around and say, okay, scan the next serial number. It's kind of like what the default examples in test stand do, right? I should address that. How come I'm not using test stand? Well, because this is GDevCon. This is for G stuff, right? We want to do things in LabVIEW. Test stand is great, but there are times when, quit is not the magic word. The magic word is exit. There you go. Okay. There's nothing wrong with test stand, but it's just another thing that you'd have to learn. And we like to do things just in LabVIEW sometimes. Okay, so let's drill down just a little bit into what these things look like. Essentially, the test sequencer is just going to launch these test steps. And what makes it a little bit different from your kind of typical DQMH module is the presence of that little blue guy up there. Let me zoom in. Whoa, that's really, okay, there we go. DTS wrapper. Okay, so this is a class. Who said there aren't classes in DQMH? There's classes everywhere. Okay, so the DTS wrapper, what this is going to do, it's going to expose a number of methods that allow the test sequencer to interact with any test step, no matter what that test step is doing. That's the whole thing. We're abstracting what the test step is doing from the sequencer. And the thing to know about DTS is that you don't have to be a LabVIEW architect to work with it. The intent here is to make it so that maybe a CLAD or a CLD can just take this and run with it and have the architect say, here's your sequencer. All I need you to do is focus on this one VI in all caps called execute test. You don't have to worry about any of the other stuff. The framework handles everything. All these other files are just to enable the functionality. And the part that you really need to edit is this execute test and the configuration for your test step. Kind of goes hand in hand. So the execute test looks like this. This is kind of the template that you get. You've got some configuration happening over there on the left, and then you've got your loop that you're going to be in while your test runs, and then all the results will come out here and deal with any errors. Oh, look at that projector fun. I don't know if that's the cable. What's that? Scroll around. It's the video feed. All right, cool. Okay. So some of the other frames in this event framework, in this event structure here, deal with functionality of pausing and resuming your test step, because we want the function of, okay, I'm in the middle of the test, but I see something weird, let me pause. The pause will get handled here. Then, okay, I'm ready to move on, I can resume. Or, oh, something's really bad, I need to get out of here and deal with a abort, right? Or if for some reason the entire application wants to stop, it's going to send a stop request, and it's handled just like an abort. So the basic things that you're going to need for a test sequencer, right? We're not completely rewriting test stand, but we want some of the features, right? So in this case, it does a pretty simple thing. It just runs this random number generator for a while, and it always says pass. Okay, well we can do, we can go a little bit more complicated than that, but I want to make sure you guys are all comfortable with the concept of the test step is there. You really only need to worry about editing this one thing. The other part of that is, of course, the configuration, right? So there is a configuration aspect to this. And one of the cool things about DTS is that anytime you get a test step, it comes with its own configuration user interface that will get presented to you when you use the sequence editor. And we'll go in a little bit more detail on that, but just to show you where this thing lives, this guy is down here inside the configuration library that once again comes with every test step. And of course, it has its own little user interface. And so when you're in that sequence editor, that's what you're going to see. All right. And so this is the plain one that, like I said, this is out of the box. This is what you get. It's going to run. You can run it alone. I just ran it alone. The other thing that is worth mentioning is that when you create a test step, it is a DQMH module and therefore has its own tester. So you have the ability to run it in complete isolation from the sequencer. You can just say, okay, I want to start my module. Now the module's running, but it hasn't been told to actually execute the test yet, because execute test is actually part of a request. So you got to say run test. Now it's executing. Okay. And then once again, it's that block diagram. This is the block diagram of the test step. And when I said run test, it actually did this, called that, which is the execute test VI. Okay. All right, so good enough with that. What we want to talk about are the things that we did at PrimeTest Automation to add on to that, to make it even more functional. I think it was Jeff mentioned that he's got a license of DTS, which is cool. But he's like, yeah, but what if I got more than one instance of a test step? How do I do that? Because the way this works, once again, out of the box, is if you look in the framework, let me get in the configuration here, and I believe it is sequence configuration. No, there's an easy way to find it. What I'm looking for. I keep forgetting where it gets stored. If you look in the main, right here in the initialize, you get this load test lists VI. Yeah, it's in the private. That's where it is. Okay. This is where you actually, out of the box, this is where you define what your sequence is. So you give it this wrapper. The parent class of the wrapper is the sequence itself. That's important. All the children are the test steps. So what you're actually putting on, you're building an array of these wrapper classes. And the sequencer is using that to determine the actual test sequence. So pretty straightforward. And then, in this other case here, if you don't want to hard code that, you want to load it from disk, you have a factory pattern here that you can point it at a folder and say, load all the test steps in this folder, and that'll work too. I'm not quite clear on how it does the ordering of the test steps if you do that. But that becomes insignificant because we made some changes. All right, so let's go back to slide world. Okay, there we go. All right, so what are the advantages of DTS? You've got the fact that test steps are just DQMH modules, which if you're working in DQMH, you're familiar with. And if you're not, there's tons of resources to learn DQMH. It's 100% LabVIEW. There's no third-party stuff going on. Like I said, each test step has a configuration UI, which is really, really powerful. You've also got a logging module there that takes care of managing all your test results. And these things are actually test stand friendly. It's actually designed to where you can call those test steps from test stand if you so choose. But what are the limitations? Some things that we ran into when we went to actually implement this. We're like, okay, well, the test step list is the sequence in that VI that I just showed. And that feels kind of limiting because it's like, well, okay, great. If I only want to do these 3 different test steps and I want to do 1, 2, 3, I'm fine. But if I want to do 1 and then run step 2 5 times and then do step 3, it doesn't really work. Even if you take the obvious shortcut of I'm building that array of those wrapper classes and I can copy that second one 5 times, it's still going to get really confusing because the names of the test steps will just be repeated and you won't know which result came from which instance, and it's not a good scene. So other limitation is out of the box, you get results just in a flat file. That's fine for a lot of things, but sometimes you want to go with a database or something more sophisticated. And then the other thing that really hit us hard was this framework's not compatible with RT until we mess with it. Okay, so The reason is there's actually two things that make it tough for RT. One is it uses subpanels, and RT is allergic to subpanels. And then the other is that it's all one library, so your configuration code and your execution code are one as far as dependencies are concerned. And if you're working with RT, typically your user interface is running on some non-RT thing, unless you're using embedded UI, which that's fine, then you don't have to worry about that. But if you're running a Windows PC with your HMI, talking over the network to an RT target, you don't want to have that Windows system pull in all those dependencies to do the test step execution, because the execution code is going to have things like instrument drivers and DAC and all this other stuff, and you may not even have any of that on the Windows side, and then you're just going to get all kinds of complaining when you try to run that. So what did we do? We said, okay, let's take a look at that sequence editor. We're going to add the ability to let you edit the names of the test steps. We're going to let you select the test step type for each step. So now that I've given you the ability to name whatever you want, I'm going to choose which one of the step types. So that array of wrapper classes becomes really an array of test step types, not test steps themselves. I'll let you add and remove test steps. How about that? And we can change the order. Okay. Then instead of a flat file, we'll do a database for results. It makes it a lot easier to go and find your results later. We also made it so that the tables in that database are dynamically defined by how you set up your test step. I'll show that. That was a fun one. And then typically in these tester applications, what I should have mentioned is, at PrimeTest Automation, most of our stuff involves some kind of moving parts. We've got robots, we've got conveyors, we've got indexers, it's industrial equipment. There's a lot of things other than the tester that are happening. So the tester is sometimes just in an idle state, waiting for something to be loaded, but you also would like the ability to take that tester and do some engineering manipulations to it, diagnostics, calibration, all this other kind of stuff. And while you're doing all that, you're not running test sequences. So you need something on your user interface that says, oh, I want to be in an engineering mode right now, or I want to be in a calibration mode. I'm not really running my test sequence. So you don't want that sequencer running all the time. So I've got to give it the ability to just go idle. You notice in that example I ran, it just kept coming back to the, hey, scan serial number, scan serial number. It's like, all right, how about you be quiet, let me do my engineering work for a minute, and I'll come back to you. And then, of course, we made an RT version. So let's demo that. Okay. We'll start with the non-RT version. I will show some code, but I'm going to start with a video. And this video is going to be the full-up, production-ready, running a real test on a real part for a real customer. I'm not faking it. Okay, here we go. I think it's this one. All right, so you're going to see the user interface pop up. You'll notice the test sequence is on one side. So there's the sequencer has been made larger. This is the sequence editor here. So just showing you like some of the steps. Oh, this is the scaled down one. Now let me do the full blown one for you before we do the scaled down one. There we go. Let's go full screen on this thing. There you go. This is the real, running a test on a real part. You can actually see a live image of the real part on the right side. You see the test sequence on the left side. So that is in the live moving image. We're using the iMac stuff. We're using the vision development toolkit for that. Katya talked about that yesterday. So this is just doing a simple color analysis. We're looking for reds and greens. Then this is the same camera, just kind of cropped in the region of interest and acquiring at a much higher frame rate as a result of that. We can count the blinks on this LED, which is kind of cool. The other things that are going on, just for your information, is we're injecting AC current, and we're also, and then separately, we're also implying high voltage. The device reacts. This is a device with a couple of electrical contacts that's designed to protect things in the presence of high current and then reconnect in the presence of voltage with low current. So the device will actually change position, and we have to push it back up into the nest. That's what you're seeing there. And you get the green. I'm fast forwarding. There's a 45-second wait that is a result of some design changes that are happening in the part. If you watch closely on the camera, you see that little lever. It pulls that little yellow lever. That puts the unit under test into a state where it will behave differently. So now this time we're counting blinks again, but you're going to see the other LED light up, and we're watching for that. And I've watched this video I don't know how many times, and I just recently noticed that other LED actually turns on and then turns off. Did you notice that, Mark? It turns off for a second, turns back on. I'm not sure if that's expected. The requirement is just that it comes on, so we're not judging that too harshly. Then we're doing this again, getting the contacts to close again. Then we're going to trip it again. Then we're going to watch it until it's going to drop out again. That is a live image, so the camera's looking at this little piece at the bottom, and it's actually going to fall forward. You can see it fall. There you go. Okay, so that's the test, and then you get results displayed over here. All right, so this is everything you see here is DQMH modules using DTS to do the test sequence. But you also see these other buttons down here, this engineering and calibration, and I'll talk about that too. All right, get out of full screen mode. All right, come back to my slides. All right, then we'll go into what did we do specifically to the framework. We added some requests. DQMH, you have requests and you have broadcasts. We've added these requests. So we added a start sequence request. So out of the box, the thing is just always running a sequence. There isn't really like a specific request to say, hey, I want you to start your sequence. It just says, I'm doing a sequence. So we're like, all right, let's make that a request so that it can be idle, so we can start sequences when we want to. The other thing we did is we made provisions for running a manual test step. So if I just want to run one step out of my sequence, I don't want to run the whole thing, we made a request for that. We made a request to load a test sequence so that you're not limited to just the one type of sequence that you've defined. You can make files and figure out which file you want to run. And then we have this concept of a preview sequence, and this is just a way to communicate sequence configuration files to other modules. The other request we did was a retest index. So if you have a hand-loaded or even an automated loaded fixture, sometimes you run a test sequence and maybe something doesn't pass, but maybe it wasn't the unit under test's fault. Maybe it was, I forgot to hook up this cable, or we had a brownout or something, and I just want to redo this test. But the thing's already in the fixture, so I don't have access to the barcode. I want to do a retest, but I want to skip a few steps. So we put in a request there that lets you specify, I want you to retest, but start at step 3 and just accept the previous data from steps 1 and 2. That can be pretty useful. And then we made a request for instructions, because the user interface with the sequencer has a little instructions box. And thought that would be nice to keep it there rather than trying to put it in a separate sub panel or something. So just, if I put a request where I can send instructions, that'll look nice. Then we added a couple broadcasts, sequence state to tell other modules what the sequence is doing. And then of course a test result, because I don't want to depend, like there is that pass banner that shows up that's built in, but if I want to have my own, or if I want to send something over a network when it passes or fails, I get a broadcast and I can react to it like that. And then, of course, apply configuration. This becomes very useful for the RT stuff, because if you're on RT, you want your editor not on RT, because RT doesn't want to be an editor, it just wants to be running things. You want to put your editor someplace else, and you just want to have a way to say, hey, I just sent you, Mr. RT target, a new configuration, so please update yourself with your new configuration. See how we're doing? Oh, we're doing okay on time. And we'll go into detail about this. The big change from the as delivered set of templates and things versus what we're using is the fact that you can edit the name of your test step. As delivered, the test step name is the module name. So you'll notice that there's this constant, that right there is the cursor doesn't work. Highlighted in red is the DQMH module constant for its name. And that's what's shown as the test name. That's really the big limitation there. So what we did was change that. We're taking advantage of that whole attribute feature of variants, because the test step configurations are carried as variants by the framework. In this case, variants are kind of appropriate because you don't know in advance what each one of your test steps is going to want for configuration data. I'm sure there's a way to do it with classes and stuff, but there's tension between how deep you go into the class world versus how usable it is for the non-CLAs of the world, I'll call it. But I noticed that we already have a variant. So since we already have a variant, that means we have the ability to do attributes. Let's do an attribute for the name. And then where that actually plays out is, so now the step name comes in, and we can use that to go ahead and look it up on our list of step names and figure out, okay, which step is this? And then pull out the configuration data for that step and send it on to the run test request, which this is one of the methods in that wrapper. So depending on which test step we're talking about executing, again, that's a class, that's a class method, dynamic dispatch. It's going to call the proper run test for that test step. Once it's done running, it'll shut down the module for you. So we'll get into architecture options. But before that, I'll back up and show some of those things that we added and what that looks like. Okay. We'll do it on, so this is the as delivered, I'll call it. But I've got the one here. So this is kind of a somewhat pared down version of what I showed in the video. Let's just get the main going. So you can look at the main. Okay, so the main is pretty much just a frame for a user interface with a couple subpanels. The sequencer is going to load into the subpanel on the left, and then on the subpanel on the right, I have like where you can display graphs, and it's actually where you can put the test step UIs themselves in on the right there. Okay, DQMH. Everybody's kind of somewhat getting familiar with this, right? The look of a DQMH module, you have the error, you have the event handler on top, you got the message handler in the middle, and then usually helper loops kind of come in at the bottom. This is a very simple helper loop. The only thing it's helping with is telling the time. It's like, okay, I'm either giving you the time or I am stopped. Pretty basic stuff. But this is what is going to launch the framework. So if you look over here, all right, that's where we're starting DTS. Okay. So this is actually runnable. We'll just use the launcher. Launch this guy. It comes up and it says, what does it say? Oh, it's telling me it's homing required. So typically, like I said, a lot of our systems have moving parts. Moving parts need home positions, or else you're in an unknown kind of state when you start up. So we typically come up in a state where, like, I need you to home. So if you just hit the fault acknowledgement, that little thing that flies up in your face, that's the homing sequence. I've faked all the I/O, so that goes really fast. Typically, that's like actuators moving to their home positions and stuff. But now you see the instructions have changed. So before it was telling me, oh, you got a home. Now it's saying, hey, I'm ready to start. Hit the opto button. I don't have an opto button, but I have a retest button. Like I said, the retest can be useful. The retest is kind of smart in that if you haven't run a test, it's going to start at the first step no matter what. So we can do that. In this case, customer requirement is for the operator to actually scan their ID badge every time they run a test. Like you want to know who to blame, right? Okay. And then we could put a serial number in here. And there's also a catalog number you can enter. Okay, and then it's going to run the test steps. These are, these are fake test steps. These are just like simplified things where you can just put in a number and it'll judge that number. There you go. But I wanted to be able to show you just kind of how this interacts. And then it wants to be homed again for some reason. You get your list of test results here, just as a table. You can also do a daily report because we have changed the test result logging to go into a database. You can query and say, what have I run today or yesterday? You can change the date. How many things have passed? How many things have not passed? Everything's passing. Well, we gotta, for variety, we gotta make something not pass, right? Okay. Tell that to go. This one's fine, and then this one would be like 5,000. And you're out of the limit. Okay, I'll generate a report again. Now I got one that doesn't pass. Okay, so that's querying a database. Let's look at the test configuration. There's the configuration editor. Okay, so I can edit my sequence. This is my sequence. So if I want to repeat one of my test steps, right, that could be a possibility. Let me add a test step. Look, now I can do that. And I can give this a name. Or like third try, whatever. Okay. Let's do run another test. I can select which test step type I've got. So in this case, I'll just grab my little example. That's fine. Some of you have probably encountered something called an MES, a manufacturing execution system. That's typically some cloud-based thing that factories have that can suck up test data into that. So I've got a little editor here for if you can define tags. Basically, every test step defines a list of results. And this is the list for this particular step, right? And if you've got something like an MES with let's say a web service that's listening for results, sometimes there's a mapping between the test step results list and the list of tag names that MES wants. And this is where you can establish that mapping. This is especially useful for when you've got to do one type of test step repeated times. The MES is going to need a little bit more information than just the name of the result. It's also going to need to know the specific instance of that test step and the result. So this is where you can put whatever, and this thing knows how to do like a JSON upload. Now this is very application specific, but I chose to put it on the sequence editor just to kind of illustrate you could do something like that here. I figured this is an appropriate place to do it because it's where you're defining your actual sequence. So one little quirk of this is that I've added my step, but it's not showing up over here. You just kind of have to confirm it and go back into the editor. It's a little thing, but now it's on this list. So here I'm editing the sequence itself, but as soon as I click on one of the steps, I'm editing the configuration for that test step. So this is once again using that class wrapper to say, open your configuration user interface. And because of dynamic dispatch, right, it's gonna pick the right one depending on which step type. You notice that these last three, the interface doesn't change, just the data. And I haven't defined data for this third one, so it's got default stuff. This is just like example for All right, so there's that. And I can say okay. And now it shows up on my sequence. I've got my third instance of that, and I can run my test. And say go, and then, okay, my measurement is 50. This one is going to be like 500. And then this one is also going to be 50. All good. So now I've got more data. Okay. But what did I just do? I just added a test step, and I told you I was saving stuff to a database. Now it's got to save more stuff. That's a big pain, right? Oh my God, I got to change my database table. I got to do all this stuff. But obviously, handled it. And that's just basically, that one is just the way that we structured the database. It kind of takes care of that for free. The more difficult trick is if you decided that instead of just one number on that test step that's reporting as result, you want more than that, you want more results. That's a little bit harder to handle, but we did handle that. Before we get to that, let me show one other kind of thing. We're going to hint at, how are we doing on time? Because I lost track of when I started. Okay, great. All right, cool. If I log in, look what happens. Oh, see these two buttons down here? Engineering and calibration. Look, I can go into an engineering mode. I can look at my I/O. If I have waveforms to view, I can do that. Or I can go over here like calibration. I can tear my load cell. I can look up catalog numbers, look at, this is TED's data stuff. I can mess with my tester settings. I can change all my thresholds for my color analysis for that red-green thing. There are some calibration curve data tables that get looked up to figure out the tripping times on those graphs. I can do all that kind of stuff. And my test sequence is just happily sleeping in the background. He's all good. Here in the 7x7, we'll talk about that. That's a quick preview. All right. Now, if I log out, right, if let's say I don't have privileges to be there, it boots me back to my sequence view and grays out these buttons. We can also hide those buttons, but anyway, something worth mentioning. So rather than going into just like all those requests that we added, I'll show the database thing because I think that's kind of something that even if you're not ever going to use this, if you're not ever going to do any of this DQMH stuff or any of this DTS stuff, I think it's useful for you guys to know how to go from a flat file to a database. So it's a little add-on here. Okay, there's the database. It's in reuse. All right, it's in the framework. It's in the logging. It's in private, and it's saved to database. All right. Where is it? Save to database. Okay, so what's this going to do? We don't have a ton of time. All right. All this needs to know is, hey, where's your database folder? I'm using SQLite, seems like everybody else. It's great. We're just going to grab all of our results. If this projector would behave. Okay. Maybe it doesn't like the zoom. I don't know. But this is the key step right here, prep DB table. Okay. What this is going to do is, of course, create the table if it doesn't exist, right? It's going to say, okay, if your table does exist, what columns do you have? And then it's going to load in from the configuration of the test step, which is where that columns control is. It's going to compare that to what columns it has. Hey, look, sets and maps. It's sets, just set. Okay, so we're going to take the union of the columns that exist and the ones that the test step is going to generate and make sure that our table has all those columns. Because if you try to shove data, try to insert data into a database and name a column that isn't there, you're going to get a big error. So this will preserve any existing columns that you may have gotten rid of and add any additional ones that it finds. It's just a little piece of SQL here that I totally stole from SQLite Studio and didn't even hide the name in the query. If you use SQLite Studio, it's a free tool. And just take note, if you add a column manually, it's going to say, hey, I see you want to save these changes? I'm about to execute this query. Just copy that. That's what goes in there. And then just, parameterize out your column names, and you got it. All right, so real quick, because I kind of glossed over this, how do you know what results a test step is producing? Okay, that is in the wrapper. There's kind of a constant. Test column headers. Just state here in your child instance, your method override, what are the names of your results? And if you do it in such a way that you don't use spaces and weird characters, it'll work for your database. So be careful. Okay. And that is what ends up showing up on that column list that comes in on that database. In here, this thing, columns, that's where that comes from. It's just coming from that one override method. Okay. Let me pause there just to see if anybody's got any specific questions. Yes.
All right, so the one question I have is just, I see how you've taken it and you can actually add tests now and you can repeat the same tests over and over again, if you so choose.
Yeah.
Is there still the limitation where every test you have has to be in this project with this sequencer?
Does every test have to be in that project?
So the project you got, you're working in now, right?
Right.
You're going to have test steps for each of your tests.
Yeah.
Do they all have to live inside that same project?
I have never tried to not do that, but I could see with the factory pattern, you should be able to get away with not doing that as long as you are set to inherit from that DTS wrapper. You've got to be set to inherit from that.
Right.
And then I think it should work. I haven't tried it.
Okay.
I do want to show real quick the RT stuff because it was really just two main changes that make that work. So let me show that real quick. The big deal here is that execute test VI becomes a method in a class. And you're going to feed that class instance to, to the execute an execute piece of private data, which is an execute class in your DTS wrapper. So we added a class for just execution and into the wrapper, and this is where you define it. You do it like this on the RT side, and that execution class will pull in all your dependencies. Like for example here, there's the execute test VI. That's part of that execute class. And this is where you've got all your hardware extraction layers and instrument driver calls and all that stuff. But on Windows, if you just want to edit the configuration for this, fine. Just don't wire these. So just make your test list look like it did before with just the wrappers and no execution class. And now you've separated your execution code from your configuration code. Okay, now are there any more questions? Nobody, everybody's done. Yes, Katya.
In the creation of the new columns in your database, how do you set the type?
Okay, so SQLite is very generous in not caring so much about type, number one. Number two, DTS by default just makes everything an array of strings. So everything is just a string as far as type. Now, to get around the fact that that's really annoying for waveforms, when dealing with waveforms, we will save the file name of a TDMS file as a string and then have a folder for waveforms and dump the TDMS to that. And then actually worth kind of showing real quick is that results display that you see, not that one. The results display knows when you've clicked on a line item that has a TDMS file, and it will load that TDMS file and show it on the graph. I don't know which one of these is this one. Okay, so we'll look at that real fast if there's a moment. So this display here where we showed all the results at the end of the test, this shows up. You've got this graph down here. So we have an event for that table that if you've clicked on a cell that says TDMS, we'll go ahead and pull that waveform in and show it on the graph. So other than that, for the most part, if you're dealing with discrete scalar test results, strings are not terrible. Anybody else? All right, cool. Do you want me to just hang out and do the first 7? Okay.
Yeah. Well, first, thanks very much, Dan.
All right. Take a quick break. Thank you.